In this presentation, we're going to discuss about preprocessor. Pre-processing of the source code happens before compilation. It generates the file to compile, looking at the preprocessor directives in the source code. It is implemented as part of the C compiler or the cl.exe. The first preprocessor directive we're going to discuss is hash include. So we have used this before to include header files. All it does is a copy paste of the content of the file which is included. So we will see a demo of the working of hash include. So I'm going to add a header file, custom header file here. So I'm going to name it myheader.h. So I have selected the header file from the items here. What I'm going to do is I'm going to declare a function. We'll be explaining what is this hash include stdafx.h in a later presentation when we discuss precompiled headers. For the time being, you can assume that the content of the file is just the declaration of this function. So I'm going to define this function here. So I'm going to call this function this program won't compile because the declaration of function is not present before main. What I'm going to do is I'm going to include our new header file. Now we can see that the function is compiling correctly. So now what we're going to do is we're going to look at the output of the preprocessor. So for that we have to go to project properties, preprocessor, preprocess to a file, or the /p switch of the compiler. So I'm going to apply it. So I'm going to do a build. So I'm going to get a build error because there is an object file to link. So instead of that, if we go into the project location, inside the debug folder, see macros2.i. I'm going to open that in Notepad. This .i file is the output of the preprocessor. So if I come to the extreme end of this file, we can see our program. So this is our program. So the hash include statement has replaced this particular line. So if you go to the code, you can see that this particular line is replaced with the content of that file in the output of the preprocessor. Don't worry about the lines before that. That is because of the precompiled headers. So in this case, all you have to note down is this part. So throughout this presentation, we will be looking at the output of the precompiled header. This particular line of code replaces the content of the file, which is this, after preprocessing. So if I want, I can give the absolute path of my header file here. So if I do this, so I have to give additional slash here. So this will also work, but it's not recommended because you cannot change the location of this program from one system to another. But we have to understand that this also will work. So now hash define. Hash define is mostly used for defining constants. The main purpose of hash define is to avoid magic numbers like 32, 34, etc. You can give some meaningful name like hash define bitness equal to 32, which is more readable. Wherever when you wanted to use 32, you can use bitness. At the time of pre-processing, the preprocessor will do a find and replace of bitness with 32. So this is the first case. So void main printf %d test. In this case, the test will get replaced by 10 after preprocessing. So this program will print 10. This is an example of preprocessor behave like a function. Wherever you see multi-x, it should be replaced by x star x, which is the square of x. So multi 20 will be replaced by 20 star 20. So here we have a problem. So we are expecting to be replaced by 30 star 30, but that is not the case. So let's see this example in Visual Studio. So this is a program we were seeing in the presentation. So let's see the output of this program. So A contains 400, which is x dot x, that is expected 20 into 20, 400. So B we are expecting 900, but we are getting 230. The reason is this statement goes into 20 plus 10 star 20 plus 10. So this multiplication happens in the beginning. So you'll get 200, 200 plus 30, 230. So that is the output. To fix this problem, you can add a parenthesis here and here. Before that, we will see the preprocessor output of this program. So I'm going to properties, preprocessor, preprocess to a file. So I'm going to build it. Obviously the build fails, which is expected. So we are going into the debug folder and looking for the .i file, which is the output of the preprocessor. So again, we have to go to the extreme end of the file. This is a very big file. So this is the output of the preprocessor. It has replaced 20 into 20, and this it replaced with 20 plus 10 star 20 plus 10. So this will give 230 instead of 900. So now let's fix this problem. So first we have to change the option back to normal. I'm going to put a parenthesis here and here. Now I'm getting the expected output 900, 400 and 900 respectively. Now again look at the preprocessed output. So I'm going to make it /v again, building it, opening the .i file in Notepad, going to the extreme end of the file. So you can see that the bracket came here. So the bracket is here as well, which is harmless. So this is the input which is going into the compiler for compilation. So we have seen this program. We have seen the problem in this program. So this is a fix which we have seen as well. So another use of hash define is conditional compilation. So in this program I have a hash define test here. So if I remove this particular statement, this part of the code is not compiled, but this part of the code is compiled. So this is called conditional compilation. Let's see this program executing in Visual Studio. So we will see the pre-processed output. So in this case we have hash defined test is available. So this condition becomes true. So this part of the program is compiled and this part of the program is not compiled. So Visual Studio understand this. That's why it's a little bit dim in Visual Studio. Look at the pre-processed output. So if you look at this, you can see just print of test defined. You cannot see any of this line. Now I am removing this. I'm commenting out this hash defined. So if I go to the end of the program, I can see this particular line is there in the program. So the program is not compiled yet. So as you can see, there is no compiler error, but we are purposefully making a compiler error here. So this should have been compiled correctly if test was defined. So that is the purpose of showing this. This particular line is not available here. So there is another way to give compiler preprocessors, that is here. So if I edit here, if I add test here, again it is like the hash define. So if I go into the I have defined test as a compiler option instead of doing it here. So that is applicable to all the files. So that is another way of defining a macro. Now this is a program which demonstrates the readability issue. So we have included a header file called myheader.h, and we have a program, or looks like a program, start main, print hello world, end main. So what do you think about the above program? Is it even a C program? Any chance that it will get compiled? All depends on what is the content of myheader.h. So if the myheader.h has these three statements, everything will be fine. So start main is void main, open curly braces, printf hello world is printf hello world, end main is close curly braces. This and this makes this a normal C program after pre-processing. So let's see that in Visual Studio. So I'm going to build the program. So build succeeded. Now let's see the output of the program. We can put even a breakpoint here. As you can see, it has printed hello world. So to better understand this program, we have to look at the preprocessor output. So I'm going and changing the preprocessor output again. So this is the preprocessed output file, the .i file. So I'm going to edit this file. Coming to the extreme bottom, as you can see, this is a program. So after pre-processing, these three lines replaced by these three lines using these definitions. So basically this kind of techniques sometimes affect the readability. So I don't recommend using this kind of techniques, irrespective of the advantages it gives. So we have seen this program in play. So we have seen this demo one by one. We have seen conditional compilation, hash defines, different types of hash defines, and we looked at the output of the preprocessor. So this is another preprocessing technique called Stringify. The technique is this. So you give a string to this particular macro. That string will be copied here after a single hash, and it will make a data type out of it with a double hash. Rather than explaining this program and making it more complicated than what it is, we'll look at the output of the preprocessor. So this is the program. So if you look at this is the program. So this is the output of the preprocessor. So I'm copying it to Visual Studio just to compare the actual program. So this test string came here with this hash string, and they have created a variable. A variable has been created with this. So both of this got replaced with this and this respectively. So in Stringify you use a double hash and a single hash. Single hash will replace it as a string like this with double quotes. You don't have to put the double quotes. It will be done by the preprocessor. Here the double quotes won't be there, but it will just replace the string. I have seen this in a lot of header files, this particular technique. In production code I have rarely seen this technique, but you'll see this a lot in header files, standard header files. Now hash pragma. So hash pragma is another directive in which we can give very compiler specific instructions in the code. So we have to refer the compiler manual for what it supports. Most of the hash pragma are internally compiler switches which can be given through the source code, or linker switches. Most are related to platform, binary, compiler and linker. So platform in the sense the loader, instructions to the loader, how to load the binary. So binary creation, specifications, compiler and linker switches. Those are mainly the hash pragmas. So the hash pragma directives, you may not learn this in your C books because it is operating system specific, compiler specific and platform specific. So it's not part of the C standard. Hash pragma itself is a C standard, but what coming after that is not part of the C standard. You will see a lot of hash pragma in production code. So we are discussing some of the Microsoft specific hash pragma. So I'm not going to explain each and every one of them. So hash pragma once, hash pragma comment, hash pragma section, alloc test are examples. To see what this hash pragmas does, I would recommend you to visit the documentation of the C compiler of Microsoft. So this is the link to that documentation at the time of this presentation, or you can search in a search engine hash pragma Microsoft compiler or hash pragma GCC to get the compiler specific information. Try to use as less as possible hash pragma because it's platform dependent, so the code won't be portable. So if you use a Microsoft hash pragma and if you try to port that code to Linux or any other platform, the code may not work because that particular Pragma is not available in that particular platform. So that's all about preprocessor. Thank you very much.